So in this scenario, we have a picture of a graph that represents fence installation. The x-axis is linear feet and the y-axis is a cost, and it says a company charges a flat installation fee plus a cost per linear foot of fencing, and we're supposed to find that cost for 1 linear foot. So because the pictures align, I could write this scenario in the form y equals mx plus b, where m is my slope, or also called the rate, and then b is my y-intercept, also called my initial fee. So if I look at the graph, I'm going to fill in the easiest part, the y-intercept. So where does it cross the y-axis? It crosses the y-axis right here at 150. So I know my y-intercept is 150. So that means their initial fee, their flat installation fee, is $150. All right, so finding the rate or the slope. So to find the slope given a graph, you are using rise over run, and it takes 2 points to find the slope. So pick any 2 points on this graph. So I'm going to use the y-intercept and then this point here. When you bubble in the points, they have to lie in the intersection of a vertical and horizontal line. So rise over run. So starting at the lower point, I count how much I rise. So you would not count this as 3 units because the scale on the y-axis is not going by ones. If you look at the scale, it's going by 25s because right here is 25 and then there's 50. So you're counting 25, 50, 75. So that would be 75 over. And then again on the x-axis, when you count your run, you're technically jumping over 1. But if you read the y-axis, you're counting by 5s. So 75 over 5, which if you reduce that, you get 15. So I can complete my equation here. So y equals 15x plus 50. So again, the slope or the rate is $15 for 1 linear foot, and then their initial fee or flat fee, their flat fee was $150. So my final answer, it costs $15 for 1 linear foot.